Look at my 2D LED pattern. It looks cool and colorful. You can see that all the LEDs are coming out in different color, and there's this kind of life to this, which is, very, very attractive. Obviously, I can apply these ideas to any pattern. We can take one more example. Now, here's the color changing ideas applied to this XOR pattern. You notice that the central area of the LED matrix, which lights up, always comes in a different color. Now, obviously, a lot of things can be customized in this, but in this video, we are going to see how we are going to implement something like this. In fact, the structure is already ready. It's just a matter of thinking through carefully and adding a little bit of code. We are enhancing the bit by bit project from the YByte Python curriculum available at www.ybyte.in from a single LED row coming up in just one color. We now have this colorful LED matrix, and that is the power of systematic development, which is so creative as well. Let's see how we do this. Before looking at any code for how we can implement this kind of color changes, let us realize that there are three levels at which this color change can happen. First is across the LEDs, which is the innermost for loop, and this is what we are also doing for, let's say, the single row, right? So this is done inside the innermost loop using the variable kk. And then we have across the rows of the matrix, which means I can have every row of the matrix in a different row, in a different color. And this will be done from the middle loop, which is the which is where every row pattern is being decided. And finally, I can do it over time for the entire matrix. So which means in the outermost loop. Now, if you think about it, in the single, let's say, row of LEDs, we just had the outermost loop, which was there was no middle loop, so there was this and this, and we saw the effect of both of these. But now there's another dimension added, which is the middle, the middle loop, which is for row. Now, the basic mechanism that we used previously was also based on, let's say, circular shift left or right. So I'm going to use circular shift left. Like we discussed, there are three places. So I've already put the statement in a template form over here. So this is the first one, line 206. This is inside the innermost loop. That's why this is basically going across the LEDs, and hence the color is a function of, let's say, KK. However, right now I've set it to 24 here, which means there'll be no change, because remember, in a 24-bit system, if I shift it by 24 in a circular manner, there's no change, right? And this is a 24-bit system because the color itself is 24 bits. This one here, line number 194, is across the rows. Again, this is because it's inside the middle for loop, the variable. Every row, right now the color will be same, but I can make the color different. And finally, this one, line 158 here, is a similar statement, but that is at the outermost loop, so which is going to be across, let's say, the renditions of the matrix, right? So let's play with this one by one. Right now they are all disabled. When I run this piece of code, you notice I do get a color, but the color is constant. Of course, this color, is coming because the initial color has been set to be, let's say, this number, right? So we can change this. Of course, I can make it, let's say, G and B. The color would change. Just for experiment, we can do that. So let's say I do 1111, 1111, or any other combination. That's fine. So 0000, 0000. So now when I run this now, of course, the color changes to cyan, but you notice there's no change across rows, across LEDs, or across time, right? Now let us enable something interesting. Let's say I say, okay, look, let me now change this across time, but not across rows. So I'm just going to say turn on this one here. So this is going to basically make the entire matrix appear in the same color, but that color would keep changing. Notice, because the outermost loop I'm making it 1, which means this color will change from cyan, it will go to something else, and so on. We can run this. When I run this, you notice slowly but surely the color keeps changing, but the entire matrix otherwise appears in the same color. Very interesting, right? The every row is the same, every column is the same, because there's no other change. Across time, however, the color keeps changing, right? So, and you can see it very clearly here. The color is changing, as the program is running. I can now go to the next level and say that, look, across the rows also I want the color to change. And let's say I want to change rather fast. So I make it, let's say, 2. When I now run this, you notice every row is coming in a different color, and that color is changing right now, because remember, the outermost loop is changing across time, the middle loop is changing across rows, which is why you notice every row is coming in a different color. However, across the row, which means across LEDs, there is absolutely no change in the colors, right? I can go one more level here, and across LEDs also I can change. let's say I go and set this to, say, for example, here it's 24 right now. Let me just, for the, you know, experiment sake, let's say I make it 3. So this color is going to change quite a bit now. When I run this, you notice now this is super duper colorful. In fact, the colors are changing across LEDs. Every row is different and over time, right? So very, very interesting, very logical the way this whole thing comes together. Obviously, there are many, many, many possibilities that one can try. You can really play with this to kind of give it completely, different types of patterns. Now, before wrapping this up, let's look at something pretty cool. You notice here I have turned on every LED. So every LED is on, basically the pattern static. However, I am creating a situation where across LEDs is a different color. Every row is in a different color, and these colors are changing across time. So really, really nice, colorful pattern we've created using just bitwise operators. You see, again, such a long change from such a large change from, let's say, where we started to where we are right now. And that's the power of systematic development, how creative this process is, how colorful, how beautiful this pattern looks. I hope you found this interesting. At YByte, we learn Python programming by building fun activities like this, which make us think, which make us enjoy, which make us have fun while we learn Python programming. Look at our website because we learn Python programming through such fun activities. Take care. Thank you so much. Bye bye.